committee, dear candidate, I hereby declare open the session dedicated to the public defense of Alpha Mamadou Diallo on the topic of classifying, improving and evaluating indoor tracking systems. So let me first present you the Thesis committee. So it's composed of Benoît Carbonato, full professor here in HEC Lausanne, and he's the Thesis supervisor. Kevin Huguenin, full professor here in HEC Lausanne, and he was acting as an internal expert for the thesis. Sonia Ben Mokhtar, research director, laboratoire d'informatique en images et systèmes d'information, CNRS, external expert. Pascal Selber, Department of Computer Science, University of Neuchâtel, external expert as well. And I'm myself, Valérie Chavez-Demoulin, I'm professor here in HEC, and I'm also vice dean for research here, and I'm going to chair this session. So the candidates, Alpha Mamadou Diallo, hold a professional degree in computer science from the University Monco Conakry and a master's degree in information system from the University of Neuchâtel. And the procedure, you know how it works. You have 30 minutes to present your work, and then it will be time for the questions, first from the broad audience, and maybe from the thesis committee, and then we're going to deliberate out of the room, the thesis committee and myself, and then we go back and provide you with the decision of the committee, and that's it. Okay? Okay, the floor is yours.
I just need to set up some stuff. Well, that's better. Well, thank you very much for coming to this presentation. I'm really glad to have you here. And today I'm going to present what I did during these past 5 years. And the title of my thesis is classifying, improving and evaluating indoor tracking systems. And since we have a large audience, we have people from family, some friends, we have some experts, and we also have some deep experts in the field. So I'll try my best to do this presentation to make you all at least understand some points on my thesis. So first of all, I'll try to answer some questions that came quite often during these past years. The first one came from my family and friends. It was, how long does it PhD take to complete? What I will do is, I used to be a student, so that will be the first part of my presentation. And then the second one will be, what's your PhD about? And I will try to explain it in simple terms. And for the third one, I will show you my contribution, what I did during these past 4 or 5 years. Here is the table of content, so I will start by talking a little bit about the journey. Then I will introduce the topic without entering too much into detail. I will try to make it simple. Then I will present the research objectives of my thesis. And then I will enter more into detail for the experts. And I will show the contribution of the whole thesis. And finally, I will show the limitations and perspectives of my work. So about the journey, I received a lot of questions from friends and family, and they were trying to understand what am I doing at university for 7 years. That's a lot, and I will tell you that I really didn't waste my time. First of all, that was the plan I had. It looks very simple, so it was plain. My idea was just to come to university, read some paper, run some experiment, write papers, and graduate. It didn't go that well. This is how it went. So when I started doing research, I noticed that sometimes there's a lack of resource, there's no code, sometimes you don't even have access to papers, sometimes you don't have data, and the thing is that you have a lot of issues, but you need to find solution at the same time. So when I encountered these issues, I had to collect data, and I had to prepare this data collection, and also, and after doing this data collection, I had to write papers and eventually submit. Then I realized that I was lacking some skills, for example, some writing skills, and sometimes my code doesn't work. So I had this null pointer exception, and I had to fix these issues. And then during the journey, I had to learn, I had to improve, and then I submitted papers, and received some rejection. This happened sometimes. And I had to learn, I kept learning during these past 4 or 5 years. And I improved myself, I restructured, I rewrote, I improved the code, I fixed some errors, and I redid some experiments sometimes, and then I managed to resubmit the papers, and some of these papers got accepted. And this is just one part of the journey. So the real journey looks like this. So you have a lot of things to do, you need to publish many papers, and in between, what I had to do was to take some mandatory courses. I had to teach as well, I had to prepare exams, I had to grade them, I had to take some optional courses, and of course, I had to have a social life. So this is what I did in these past 4 or 5 years. Now I will introduce the topic. So the topic of my thesis, as you saw on the title, the title is it's all about indoor tracking. So I start by defining indoor tracking. So indoor tracking for me, it refers to a set of techniques and technologies for estimating a sequence of locations of a mobile device in GNSS denial environments. So GNSS simply stands for Global Navigation Satellite Systems. As we all know, these GNSS solutions, like the GPS, doesn't work indoor. So for GPS to work, it requires a clear line of sight with satellites, so you need to have at least 4 satellites, so 3 for positioning and 1 for time synchronization. So you need to have 4 satellites, and you don't have this condition in indoor environments, because you need a clear line of sight with the satellite. So the most popular GNSS is the GPS, so Global Positioning System, and we also have Galileo, which is a bit more accurate than the GPS, and it's European. And in recent years, we observe, and actually it's very important to have the GPS, and we all use the GPS, I guess, but it makes also a lot of sense to have solutions that work indoors, because we spend more than 90% of our time indoors, and we don't have any solution that works perfectly indoors. So, and in 2000, there's something interesting that happened. So in 2000, this man, President Bill Clinton, in the United States, he signed an act called the Presidential Decision on Directive and so on. So the idea of this act was to remove the selective availability. As we all know, the GPS started with the army. So they use it, back then they weren't using it for civilian use. But for civilian use, you could still use it, but you had a very bad accuracy, around 100 meters. But after signing this act, what happened is that people started using GPS, and it started early 2000. And after that, I noticed that people started getting interested in indoor tracking. I guess it's because they started using GPS, and then they noticed it doesn't work indoor. And then they started writing papers and looking for solutions to track people or assets indoors. Now, indoor tracking systems can be used for retail, at airports, in museums, for healthcare, smart building, education. We can use it almost everywhere. And in 2020, it had a market size of around 15 billion US dollar, and we expect an increase of up to 14% by 2030. So this topic is growing and is getting more and more popular and more important. But there's something missing. There's no standard in indoor tracking system. We still have a lot of solutions, but we don't have something that works like the GPS indoors. There exist some solutions. We classify them into 3 categories. The first one is infrastructure-based. Second one, infrastructure-less, and the third one is hybrid. I will just present these three types of tracking systems. The first one looks a bit like this. This is a big picture. So the idea is to have a beacon or a gateway that you put on a ceiling, and this beacon sends signals, and a mobile device can just pick up this signal and try to locate itself. So the signal looks a bit like this. So here you have a lot of data, and you have in green you have the UID, which is the unique identifier, and you also have the red part is the transmission power, which is useful to estimate the distance between the emitter and the receiver. And this signal is picked up by a mobile device, and then the mobile device sends this the UID and the RSSI to a remote server, and the remote server looks up in the database, and then it compares the UID with existing UID and the known location, and it computes the estimated location, and then it sends back an estimated location. But to make it work, you need to have many beacons and you need to deploy this beacon everywhere in the building. The advantage of this approach is quite accurate when you combine it with some techniques like fingerprinting. But well, it's also scalable. So if you want to deploy it in the building, you just need to put the beacon. But the issue with this approach is that it's costly. So you need to it takes some time to install the devices, and also it takes a lot of time to maintain these devices. So it can be quite expensive in terms of money and also in terms of time. And the other issue is that it's mostly centralized. So when the server fails, the whole system stops working. On the other hand, you have infrastructure-less indoor tracking systems. The idea of infrastructure-less is that we only use inertial sensors that are already on the device. We don't use any external infrastructure. So we use the accelerometer and the gyroscope. And the accelerometer is we only use it to estimate the step. And the gyroscope measures the angular velocity of the device. So how we measure the orientation and the rotation of the device. This is how trajectory looks with inertial sensors when you compute the one algorithm using these inertial sensors. So as you can see here, this is so the solid line is the ground truth and the dashed line is the inertial trajectory. So the beginning, it's quite accurate, then it starts drifting over time. And at the end, we finally lose the accuracy in large environments. The advantage of this approach, since you don't need devices, you don't need to install equipment, it's affordable. It's also easy to deploy, since it relies on sensors that are always on the device. But as you can see, it's not very accurate in large environments. And also it depends on the type of sensor. We did some experiments and we noticed that, for example, with iPhones, we had some better accuracy. We had a better accuracy than on Android. And the third type is the hybrid type. So the hybrid can be, it's just a mix of at least two technologies. So it can be Bluetooth with Wi-Fi, Bluetooth with inertial sensors and so on. But for this thesis, we only use inertial sensor plus wireless based in the tracking system, and then we combine that. That's the reason why we call that hybrid in the tracking systems. Now we'll present the research objectives of our thesis, of this thesis. So it first starts with in the first chapter, we started by classifying and comparing indoor tracking systems. As I said before, unlike GPS, there are many types of indoor tracking systems. As you can see here, we have at least 10 indoor tracking systems. So the most difficult was if you want to have a standard of tracking systems, we need to understand these tracking systems. So the first step of my thesis was to classify these existing solutions. So for that, we wrote a survey of the literature, and we tried to answer these questions. What is the state of the research in indoor tracking systems, and how can we compare and classify existing solutions? Also, what are the major points to consider when we build an indoor tracking systems? And also, what are the trends across the research community? That was the first part of the first chapter of my thesis. And for the second chapter, we wanted to balance accuracy and cost. So we wanted a solution that is quite accurate and that's not costly also. So So for that, we published 3 papers, which are part of the second chapter. And in this part, we try to answer these 3 questions. The first one was how to reduce the cost of wireless-based indoor tracking systems, and how to improve the accuracy of these of inertial-based indoor tracking systems. And finally, how can we benefit from collaboration between mobile devices? And in the last part of our research, we noticed that it's very difficult to reproduce experiments in the literature, and all the papers that we found were very difficult to reproduce. And we thought about building a tool, so a framework to standardize this process of building indoor tracking systems. And we answered 2 questions. The first is, how can we standardize this process of building indoor tracking systems? Because there are many ways of building indoor tracking systems, and usually people build their solution, they deploy the code, they share the paper, but it's almost impossible to reproduce this experiment. And even in the literature, there is this paper by Baker that shows that up to 70% of researchers have tried and failed to reproduce other scientists' experiments. And half of them even failed to reproduce their own experiments. And in indoor tracking, there's a recent paper that showed that around it was less than 10% of the paper that share the code and the data. So this topic is very important for indoor tracking systems, and we address this issue by proposing a novel framework that was published and presented in Oslo recently, in Norway. And I will present this framework later. And the second question was how to evaluate this indoor tracking system. So there are many types of indoor tracking systems, many ways of building them, and there are also many ways of evaluating this system. So it's very difficult to compare your solution with someone else's solution. So we propose this framework to solve this issue. So the 3 main research objectives that we use for our 3 chapters were the following: to classify, balancing, and evaluating. Now, for people who like to, for the experts, I will enter a little bit more into details on one of our papers. So the title of this paper that I'm going to present is Drift Correction of Inertial Indoor Tracking Using Peer Collaboration and Strategic Beacon Placement. This paper was accepted and published in the proceedings of the IPIN conference. So IPIN stands for Indoor Position and Indoor Navigation, and I presented it last year in Hong Kong. And this conference is one of the it's a leading conference in indoor positioning. And in this paper, what we try to do, we try to attenuate the drift of an inertial-based indoor tracking system, and we try to compensate for the absence of mobile devices by positioning a low number of beacons, since our goal is to balance accuracy and cost. I'll just show you how collaboration works. This just to give you a good idea of how it works. So here we have 2 devices, or 2 users, user 1 and user 2. When these devices start moving, they follow the ground truth. So the ground truth are the dash lines. You'll see it will drift over time. And the idea is when 2 devices meet each other, they exchange data and they correct the drift. So it will be a bit fast. Let's start. So it's like this. So when they start moving, they start drifting over time, and when they meet, they exchange data and they position themselves. This just, I'm not using real data here, even though I'm using the real layout of the internet building in 3D. So now for the second part, we noticed that it's not very realistic to have collaboration in an indoor environment, because usually it's not very common to have people who are using the same app at the same time. So we decided to add some beacons, but since our goal is still to balance accuracy and cost, we wanted to find a trade-off between this number of beacon and accuracy. And with the beacons, the idea is like this. So we have this device that starts moving, and then when it encounters a beacon, it takes the location of the beacon, and then it takes the data, the exact location of the beacon, it positions itself at this location. This has been done in the literature, by the way. But in the literature, we notice that usually people don't evaluate their solution with many trajectories. It's not very realistic what was included. And also, we are never sure how they position their beacons indoors. So for example, here we have 8 beacons, but we don't know how they position their beacons. And if you use this approach we have a lot of beacons everywhere. It doesn't really make sense. So we need to find a pragmatic trade-off. We need to find the most pragmatic locations to position these beacons. This is the question that we answered in this paper. Now for the rest of the presentation, I will stick to 3 terms. I will use ground truth trajectory to represent the real trajectory of users. Inertial trajectory will be the estimated trajectory using the inertial sensors. And the corrected trajectory will be the updated trajectory using our algorithms. And in the literature, we also noticed that there are 3 types of algorithms. So we first start with filtering algorithm on top, and then we have the positioning algorithm to estimate the location of users, and then we have the collaborative algorithms that are built below the path. Now we present the algorithm that we chose and that we implemented. The first one is a low-pass filter algorithm. So this is real data that we collected from accelerometer. This is only for accelerometer. As you can see, because of the sense of the type of sensor, the data can be noisy. So the first thing was to run a filtering algorithm, and for that we used a Butterworth low-pass filter in order to smooth the signal. And after smoothing the signal, we detected some peaks, and based on the peaks, we used this peak to detect steps in order to generate the trajectory. And then finally, we ran this pedestrian-led reckoning algorithm. So the PDR, pedestrian-led reckoning algorithm, is a very simple algorithm. So the idea is just to, in order to know the location of a user, we need to have only the previous location, the step length, and the orientation that we get from the gyroscope. And by iterating by running this algorithm many times, we can reproduce the trajectory of the user. We can estimate the trajectory of the user. So this is how real trajectory looks. So we have 2 trajectories, green and blue. And you can see at the beginning, the trajectory are quite accurate. The trajectory looks like the ground truth, and then they start drifting over time. And here, when these 2 devices enter into a corridor, they collaborate. So here we have overlapping trajectories, and the idea is to just run this collaborative algorithm that we implemented in order to correct these estimates. And after that, we also propose an algorithm to position the beacon at pragmatic locations. And for that, we use some special analysis techniques, and we use the H3 algorithm that was created by Uber, and that's commonly used by Uber as well. The idea is to accelerate the queries, the spatial queries. So after running this algorithm on ground truth trajectory, so on real trajectory, we ended up having this heat map. And on this heat map, you can already spot the most visited location of users. And after running it, we ended up with these top locations. But it doesn't make sense to position beacon at these locations because they are too close to each other. So what we did, we ran a dbScan algorithm. dbScan is density-based clustering algorithm, and we ran that to find the best cluster to position the beacon, and then we position the beacon at the centroid of these clusters. And finally, to evaluate the solution, we use two methods. We use the discrete Fréchet distance, which is commonly used for measuring trajectories, and we also use the third quartile of localization error. And this is before doing the evaluation, we collected data. So we collected, we ourselves collected data. We also had some assistant collect data, and we ended up collecting 40 trajectory, real-life trajectory. And this trajectory were covering a cumulative distance of almost 5 kilometers. And we did that in the internal building, covering an area of up to 8,400 square meters. And then we took 2/3 of the trajectory for hotspot detection, and 1/3 of the trajectory for we run that in the simulation in order to capture the collaboration and also to reuse the collaboration. And finally, we ended up having these results. So using this collaborative algorithm and using the beacons, we noticed that all the devices, so all the devices corrected their location estimate, and we noticed an accuracy improvement of up to 52% using collaboration with beacons and mobile devices. And we even ran some experiments with more beacons, and so with only 4 beacons we got these results, and we noted that, and it's clear, it makes sense, when we increase the number of beacons, we also increase the accuracy. But at what cost? So here, for example, you have the accuracy with 8 beacons, and then you have the accuracy with 4 beacons. The difference is it's not significant. So since our goal was to have a solution that balances both accuracy and cost, we decided to stick to only 4 beacons. So we have a density of only 1 beacon every 2,100 square meters. And only with 4 beacons in collaboration, we ended up having an accuracy improvement of up to 52%. And the thing I like the most about, I'm mostly proud about our work, is that now you can replay our experiments. You can reuse our data, and you can reuse the real data that we collected, and you can replay this data using our framework that we developed. This framework is called MobXim, and on this framework you can have the real data that we collected. You can also play a little bit with some parameters, and then you can download the data and do your own experiment yourself. So the idea was to build these frameworks and share it to the community so that they can use it and also improve it eventually. And the idea is to just add more transparency to research. Now, I'll come back to the main contribution. So how does your research help people or make a difference? The first outcome of this research is a model, a conceptual model. So we managed to classify all kinds of indoor tracking systems using our conceptual model. So this conceptual model can be used by the research community and can be used to classify any type of indoor tracking system. So this is our first contribution. And the second contribution, in our second chapter with 3 papers that we published, was we managed to find a way to balance accuracy and cost. And these are also interesting contribution that we had. And the one that I'm most proud of is the MobXim framework that we built, and we gave access to the research community, and it's available now. If you want to try it, you can just go on mobxim.univ.ch. And for us, it was very important to emphasize reproducibility. And the idea is, well, reproducibility is a very important part of this framework, but there's also something else that we built on this framework. So it was a lot of work on software engineering, and we used a plugin architecture in order to allow users or developers to just build on top of what we already did, and it will help researchers to build faster and also to reuse existing code. Well, this job, what we did is not perfect. There's room for improvement. One of the limitations of this work is that for the signal propagation model, we use the path loss model. Sometimes not very realistic, but it's very common to use it in the literature. So we use that since it was in our main. We didn't really have a contribution on that one. But I think for other researchers who want to work on this topic, it might be interesting to have some more realistic propagation models, like the Montlake-Keenan model, which is more accurate than the path loss model. And the other one is, I know many people will not like what I'm going to say, but we built this tool using Python. And Python is really useful, it's easy, and many people are using Python. And the idea for us was to just allow many researchers to reuse, to build on top of what we did. But it comes at the cost of performance. It's not very fast. So, but we still use it in order to just allow other researchers to reuse it. But we also did a lot of optimization in order to accelerate the framework. So it might be interesting to have some other optimization techniques. We already implemented memorization, but you can also add some other. And what I would like to do is to write another paper on improving the particle filtering algorithm, which is quite popular in the literature, using this technique that I presented. And also in August 2024, there's a new technology that came out, it's BLE6, and it integrates channel sounding, which is an accurate way, it's a new way of estimating distance between devices, and it's way more accurate than what I use. I use BLE5, but for now we cannot use it because it hasn't been implemented by the industry. But it might be interesting to see what we can do with BLE6 and with channel sounding in maybe 2 or 3 years. So that was it for my presentation. It lasted almost 30 minutes. Thank you very much for your attention.
So do we have questions from the broad public? Yes?
So I was wondering if the algorithms run on the local device or on your portal.
It depends. Actually, there's a paper that we presented in 2023 in Melbourne at the Mobile Futures Conference, and we made it completely decentralized. So it was running on the device. But some algorithms that are more heavy, so for example, the simulation, we run them on the server or on a laptop. But we can definitely run the collaborative algorithm on a mobile device. And actually, that was the idea. I wanted to make it simple in order to run it on not only mobile devices, not only smartphones, but also microcontrollers. So we did the test, and it works very well. And we managed to publish a paper on that.
You say microcontrollers is Raspberry Pi? Or?
Not Raspberry Pi, like ESP32 or Arduino, which is even less powerful than Raspberry Pi. But you can also run on Raspberry Pi for sure.
5G is your friend.
Yeah. I hope I answered your question.
Yes.
Thank you very much.
I think there is a question on Zoom. I don't know if you can.
I think this is one of the open questions because they don't get it.
Okay.
Please repeat the question.
Okay. Please repeat the question. Okay. Yeah, we'll do that. Okay. So that was not a question, but maybe there are some questions from the participants on Zoom.
Feel free to ask questions on Zoom. And by the way, the first question was about we just had Mitch who was asking a question if it was possible to run the algorithm on local devices, and I tried to answer his questions. I don't know if he. Welcome, Lucas. Another question?
There's one question here.
Yeah, what a great presentation. Great job. I was wondering for the museum sector, you said that could be like an area of implementation. Can you say just a little bit more about how it could?
Well, I know why you asked this question. Actually, she works for a museum, and she also doing a PhD, by the way, on this topic. So it's very common actually to use indoor tracking in museum try to use indoor tracking, but you are never sure what kind of technology they should use. There's an interesting review from the Brooklyn Museum that implemented an indoor algorithm. It was in 2016 or 15, I'm not sure. I will send you the link later. And they managed to do that using BLE beacons. And actually, they had a very bad experience with BLE beacons, and this is what I tried to solve in my research. They had a lot of beacons, but they didn't know how to maintain this infrastructure. It was very costly, and sometimes it wasn't working very well. So that's the reason why I recommend switching to a decentralized system instead of just deploying beacons everywhere. It might be interesting to know exactly where to position beacons, so that you only have like maybe 4 beacons for the whole building instead of having like 1,000 beacons like what the Brooklyn Museum did. And actually, for museums, it can be very interesting because sometimes they just put beacons behind these arcs, and you can just come close. And when you come close, you have all the details about the illustration that you are looking at. But this is definitely an interesting use case, and I'm pretty sure BLE6 more museums will implement indoor tracking, hopefully.
Any other question? Yeah?
How did you manage the data collection in Internet?
So I'll just repeat the question for the on Zoom. So how did I manage data collection in internet?
Yeah.
It wasn't easy. So we had a student who helped us a lot. It was Thesis, I don't know if he's around. So we had to wait until the building was empty, and then we positioned beacons some places, and then we were just walking and collecting the data. But we did that quite late at night, sometime at 10 p.m. But we were collecting it when the building was empty, and we managed to do it.
So you did not ask 50 or 100 students to help you on that?
I would love to do that.
Okay, thanks.
Yeah, it wasn't easy, and I even know I collected 1 or 2 trajectories,
Yeah.
even less.
I
So
remember that.
I was asking people to do that. But it's not easy to collect data when there are many people in the building. And I will not ask Noel, I don't think Noel will accept to come on campus at 10 p.m., even though he's really nice. But
There's pizza and beer in the way.
yeah, but we managed to collect with Starbucks. And we actually, one of our strengths compared to other people, what other people did in the literature, usually people evaluate the solution with only 1 or 2 trajectories. But in our case, we did some experiment with 50 trajectories. So we had a dense data set, and that would be interesting to have even more data. But we managed to have more than 50 trajectories. Yes, Vaga.
So you said that you collected the data when there were no other people, right?
Yes.
What is the impact like? Because there will be some impact on the received signal strength or something like that, right? When there are other people and there are other interactions.
Yes. So actually, what we did, we collected inertial data. We didn't collect wireless data. We collected some data from beacons, but to capture the collaboration, it's difficult to capture collaboration because you need to have many people moving at the same time.
Yeah.
And we couldn't afford to hire many people and ask them to work at the same time. So what we did, we collected real-life inertial data and real-life data from beacons, and then we ran a simulation using our framework. So the data exchange was made in a semi-simulation. We call it execution replay, but it was a kind of simulation. But maybe interesting if you, I don't know how many people are here, but if you want to collect data, I'll not say no.
Any other question?
Another question?
No, there are 2 comments in the Zoom for you. I don't have any questions. Diallo, well done and congratulations, right? Okay, if there is no question, we can switch to the members of the thesis committee for some questions if you have.
We usually start from the person coming from the furthest. So that would be so
Yeah.
nice.
I'm not going from that far, but so thank you very much for your presentation. For manuscript, we had the opportunity to discuss quite a lot with contents, but maybe I can ask 1 or 2 additional questions. So one of the questions I have is that so you motivated a lot indoor tracking, and with this market that's going to increase and so on in the coming years. So the question I have is how far do you think you are from developing a product out of your contributions? Like, is it something that could be thought of? I mean, you saw that the fact that there is room for products, right?
Yes.
And you worked a lot on this topic. Is there any chance what you think will end up in the market sooner or later? And imagine you have all the necessary funds and the necessary like endless time and endless resources. How much is feasible?
Maybe you first repeat the question for.
So the question is about the feasibility of what I did in the industry, if you can implement it and have a product that can be sold. Well, I don't know if you ever had this discussion with my supervisor. When I was close to the end of my PhD, he told me to focus on my thesis because actually I was working on many things. and I even started working on a prototype of an ESL. ESL is electronic shelf label, so this label tag that are used in Migros. So the idea was just to plug a microcontroller and then send signal and have a kind of mesh in order to synchronize, to update the prices, but also to position, to use this indoor tracking. I'm working on it, but I think to have better results, we should wait a little bit until we have VLCs, to have self-positioning. But there are also many other people who are working on it, and I'm pretty sure sooner or later, actually, there's Google who was working on this topic, but they were using Wi-Fi. They had good results as well, and I'm pretty sure some of the people are also working on this topic. So I hope, well, I'm willing to work on it. If I have unlimited time and unlimited funds, I would love to work on it, but unfortunately I don't. But I'm pretty sure sooner or later we will have a standard solution.
And what would, from your point of view, VLCs change to your actual work? Like, would it change everything, or would you just need to adapt to make your prototypes work in VLCs? What would be the change?
So the question is, what will be the change that VLCs will bring? So I think VLC cannot change everything, but it will at least solve the issue of interranging distance between devices. And if you combine these VLCs with our approach, so using inertial-based and a very accurate interranging distance, I'm pretty sure we can have some very good solutions. But on the other hand, there are also some technology that are getting more and more popular, like ultra-wideband. I'm pretty sure ultra-wideband can also be a solution, but it doesn't change that much because we can also use ultra-wideband with what we propose. So if the industry goes toward VLCs, I'm pretty sure they can implement what I did, or if they use ultra-wideband as well.
Last question. So we talked about the possibility of using your tools in industry, and we can also ask the same question for academia. So one of your objectives is that the tools you developed get used by the research community to develop new protocols and these kind of things. So how can you say how easy it is or how difficult it is, for example, to take your tool and to introduce, for example, new building, new architecture, and to perform new data collection and to, for example, find the right places for placing beacons and so on. So how difficult is it? Like, do you need to get Alpha Diallo to be able to do that, or is it straightforward?
So to repeat the question is to know how easy it is to use this solution in other buildings and by other researchers. I think my point of view is a little biased since I use it a lot. But what we had in mind, actually there are already three people using it. Myself, me, and Stergus, and the one who knows how it works. And we really try to make it simple. So first of all, we have this platform that is openly available. And also regarding the plugin architecture, what we need to do, we really need to focus on is to write documentation and to have some code samples that other people can reuse. But the idea for us, since we decided to use Python, was to allow many researchers to use it easily. And also to deploy it should be also easy to deploy in other buildings, since we decided to use the GeoJSON format, which is getting more and more popular for the industry and also the research community. And with GeoJSON, we can just build the layout of the building and just put it and just add it in our tool, and then you have a new testing environment that you can, in which you can collect the data. And for data collection, actually, we also build a mobile app, an Android app, and also an iPhone app that we release to the public that can be easily used. So by combining this, the web platform and the mobile app, I'm pretty sure researchers can easily use our solution. And if they want to go deeper, then they need to read the documentation. And since we are still in the beta phase, we would like to have some feedback from other researchers. So if you are willing to use it, that would be really nice.
Thank you. I think in the meantime there has been one question from the public. What is the solution where there is no signal, like in Jan area? Well, that's long answer.
Well,
You could
that's the
just
topic.
provide some ideas for this.
That's the topic of another PhD.
Yeah, I thought.
Actually, in GEM area, you can only focus on inertial base because the advantage of our solution is that it can be only based on inertial sensors, and we use the Diallo signals to complement. So if you have a GEM area, for example, on the beacon, we just have a failure on one beacon, but this can be easily complemented by collaboration between devices and also by using inertial sensor. So I'm pretty sure it will affect the accuracy of the solution, but we can tackle that definitely if needed.
Thank you. Thank you very much. Pascal, any questions?
So I don't have many questions because we talked a lot during the private conference about technical aspects. I have just one open-ended question. So how do you see the industry things moving forward? Because we have many technologies, we have many protocols, we have many devices. Essentially, what we need is some kind of standard that people agree upon, that is interoperable, and that is also kind of savvy of privacy. Privacy is an issue because whenever you need to relay information because you have collaboration between different devices that talk to each other, the same way as you have this application for COVID, sending messages around, you want to make sure that your private life is preserved. People cannot see that you are in a neighborhood, for instance. So how do you see things moving forward with respect to this standardization and the coming technologies?
So
you mentioned already a few things,
So I will just repeat the question for the audience on Zoom. So the question is about the privacy aspect of this solution, or this indoor tracking solution. So privacy is very important, and I think it's interesting that you talk about COVID, because with COVID we managed to have solutions and we tackle this issue of privacy. I think we can reuse some technology or some approaches that we used during the COVID. So for example, we can have rolling UID. This might be interesting. And the good thing about our approach is that since we are not using a centralized solution, so data are not stored on a central server. So there are only users that are in the vicinity. Only user in the vicinity can know that you were around. And this user can only know that you're around if they manage to read your UID. But if you use like rolling UID, I'm pretty sure it will be a bit more complex to infer your location based on that. And the solution that we presented can run directly on the device. So in terms of privacy, it's always way better than a centralized approach. But definitely, I think the solution will be to use this rolling UID. So that you can detect someone, but you are not sure if it's the same person that comes later. So that's the idea. Thank you.
So that's all, because everything has been asked already, and I think you did a really great job. So congratulations.
And by the way, the private defense lasted 3 hours.
And that's what Kevin said also, so if you have any question,
You don't have questions? Okay. So I just have a question that is not directly related to the technical work, but it's more like a feedback to me. So imagine you're back 5 years ago, and what is the advice I should have given you that I didn't give you? To succeed in your PhD, of course. Let me frame the question.
To be honest, I was about to say buy Bitcoin.
Yeah, that's okay. Yeah, like that one.
Well, something that I could have done differently. That's a very difficult question.
Something that I should have told you that maybe I didn't.
Well, you did your job perfectly.
Oh. I'm sure I didn't. So there's probably something that, if you think about it, you think, I discovered that myself, but if someone could have told me, that would have been easier or something.
I'm seriously thinking about it, but I think if I'm here in front of you, I guess it's because you did your job. And
Yeah.
I don't think there's something you should
Or something I should have insisted on, but I maybe insisted not.
Well, you insisted on writing. It helped me a lot. And I think there's something missing.
Yes.
I think something that may be interesting also is to have collaboration with other researchers, because our situation was a bit particular because we are in HEC, information systems, and what we did was very oriented toward computer science. But this is not perfect, but for me, I think if I had more time, if I could go back to the past, I think I would definitely contact other researchers, work with other. But I managed to do that. We managed to do that, but at the end, we met with some other researchers from other universities, and we learned a lot from them. But I think this is something very important when you do research. It's important to work with other researchers from abroad, because people think differently. They will definitely bring something new to your knowledge.
Thank you.
Welcome.
Okay, thank you very much. So I think now it's time to go for deliberating.
So normally the people leave the room, but since we are smaller,
Yeah.
we will leave the room.
But please stay there.
Je sais pas, on attend. So, for those of you who don't understand what's happening, alors, toutes les personnes qui ne comprennent pas ce qui se passe, en fait, le jury décide juste de sortir, on discute entre eux, après on décide s'ils vont prendre le titre de docteur ou pas. Donc là, c'est le moment de prier, si vous pouvez prier, tous ensemble. Faut que ça se passe bien.
So after deliberation, the committee has decided to propose to the rectorate of the University of Lausanne to award you the PhD in information system. Congratulations.
Yes, so I'm going to switch to French. Most of you understand French? Oui. Ok. Donc moi j'ai une petite tradition, c'est que je dis toujours quelque chose sur des doctorants. Un doctorat, c'est quand même 4-5 ans passés ensemble, à discuter, à rencontrer des difficultés ensemble, à les papiers rejetés X fois, on ne comprend pas pourquoi, le reviewer n'a rien compris, ou alors c'est lui qui a rien compris, est-ce que c'est le reviewer? Donc j'aime bien un petit peu faire un petit bilan. Alors, pour l'historique, moi j'ai rencontré Alpha alors qu'il était étudiant dans notre master et qu'il avait suivi mon cours Emerging Distributed Architectures au printemps 2018. Il avait fait un excellent projet. L'année suivante, il a fait sa thèse de master avec moi sur, guess what, indoor tracking. Et donc dans la foulée, en mars 2020, il a commencé sa thèse sur ce sujet-là. Alors, c'était 1 an avant le Covid, ou la Covid, ça dépend comment on voit les choses, avant que la Covid nous tombe dessus, ce qui a rendu tout un petit peu plus compliqué. En particulier, à l'époque, ça a été le cas jusqu'à la fin de sa thèse, il s'occupait des exercices d'un cours de plus de 350 personnes. Alors c'est sûr, quand on est passé en mode en ligne, et puis ensuite en mode mixte, ça a pas mal compliqué les choses. Et pour celui qui donnait le cours, et pour celui qui animait les exercices avec les assistants étudiants. Enfin, on est arrivé au bout de ça. Alors ça, c'est le côté historique. Ensuite, la question que je me suis posée, c'est mais qui est vraiment Alpha? Alors, on a chacun sa vérité, on a tous multiples facettes. Alors, je vais vous donner ma vision d'Alpha, comment je l'ai perçu. Alors, pour moi, c'est quelqu'un, évidemment, qui est extrêmement curieux, qui est touche à tout, et qui n'hésite pas à mettre la main à la pâte pour tester toutes sortes de technologies, du hardware comme du Raspberry Pi, des beacons, des LS5, des LV5.1 qu'on a eu de la peine à avoir parce que le standard était là mais personne n'implémentait, des trucs exotiques comme Coupa, avec lesquels on n'a pas fait grand chose mais enfin on a quand même essayé. C'est une technologie ad hoc, enfin propriétaire pour faire de l'indoor tracking. Évidemment dans le logiciel, des frameworks Python, des trucs bas niveau pour configurer les Raspberry Pi, etc. Alors bien sûr, quand on est touche à tout et un petit peu comme ça, une des difficultés c'est de rester focalisé. Alors, ça peut être un désavantage, notamment lorsqu'on doit rester sur un fil de recherche et puis avancer sur ce fil-là. Ceci dit, puis d'ailleurs on en a encore discuté il y a 2 minutes, je l'avais écrit avant. Ce que j'apprécie énormément chez Alpha, c'est qu'il a une vraie âme de chercheur. D'accord ? C'est-à-dire qu'il prend des idées, il les teste pour de vrai, plutôt que de rester sur un chemin d'optimisation de publication. Alors évidemment, on est évalué sur nos publications, mais c'est pas ça qui le motive, fondamentalement. Et je pense que c'est une très très bonne approche. Il est curieux, il a envie de tester des idées, il les teste. Des fois ça prend du temps, beaucoup de temps. Des fois ça aboutit à rien. Mais c'est pas grave, ça fait partie du chemin. Et ça rend aussi, je pense, le travail de chercheur particulièrement intéressant. C'est quelqu'un aussi qui n'a pas peur de se lancer dans le concret. Je vois Mitch là. Je suis très content qu'il soit là. Mitch et Alpha, et moi aussi au passage, on a été amenés à tester toutes sortes de choses pour le indoor tracking à l'EHL, qui à un moment donné était intéressé par faire du indoor positioning dans leurs locaux. On a aussi fait des tests la nuit ou le soir dans les locaux locaux de l'université. Donc voilà, ça fait partie de ce travail-là. Et d'ailleurs, comme vous avez vu, il l'a présenté, sa thèse a aussi débouché sur un outil concret dont on espère qu'il sera utilisé dans le temps. Mais attention, Alpha, c'est pas un geek uniquement intéressé par l'informatique. Alpha est un lecteur assidu qui s'intéresse à toutes sortes de sujets. D'ailleurs, au cours des 5 dernières années, on a eu l'occasion de discuter de plein de sujets qui n'ont rien à voir avec l'informatique, de l'état du monde, de ses injustices, de l'origine des civilisations et de leurs évolutions, du monde dans lequel on est aujourd'hui, qui est un peu chaotique. Donc en résumé, pour moi, Alpha, c'est un geek, mais un geek humaniste. Et j'ai eu beaucoup de plaisir à travailler avec lui. Merci Alpha.
Regardez celle-là, geek humaniste. Merci. Ça va faire un discours, c'est ça? Oui. J'aime pas trop les discours. Alors, j'ai déjà beaucoup de personnes à remercier. Si je suis devant vous aujourd'hui, je vous mentirais si je vous disais que c'est uniquement grâce à mon travail, grâce à mon talent, grâce à ce que vous voulez. Mais non, c'est pas grâce à tout ça. Je pense que c'est surtout grâce à de la chance. J'ai eu beaucoup de chance. J'ai eu surtout la chance de rencontrer des personnes bienveillantes, des personnes passionnées et des personnes talentueuses. Je vais d'abord commencer par remercier mes collègues avec lesquels j'ai travaillé pendant ces 5 années, 4-5 dernières années. Ce sont ces personnes qui connaissent le mieux ce que j'ai traversé. Du coup, on a traversé ces épreuves tous ensemble. Je vais d'abord remercier Melike et Iago également. C'est un plaisir de travailler avec vous. Je vais également remercier les membres du DESI, remercier mes experts qui ont pris le temps de lire ma thèse. C'était pas toujours évident. Et c'est un plaisir de discuter avec vous pendant la défense privée. Avant la défense privée, je pensais que ça aurait été l'occasion, comme je le disais, souvent de me cuisiner. C'était pas vraiment le cas. C'était plus une discussion. J'en ai beaucoup appris. J'ai fait des corrections sur mon manuscrit. Il n'y en avait pas beaucoup, mais j'en ai fait. Et j'ai pas mal appris grâce à vous. Merci beaucoup. Alors, je vais également remercier le professeur Kevin Huguenin, avec lequel j'ai beaucoup travaillé. Et travailler avec le professeur Huguenin, c'est très intéressant avec lui, parce que c'est une personne qui aime les choses bien faites. Et travailler avec lui m'a permis non seulement de bien apprendre Python, j'ai fait pas mal de choses en Python, et j'ai été son assistant pour le cours de programmation Python. Il nous a vraiment poussé à sortir de nos zones de confort, il nous poussait à nous mettre à jour, à chercher et à améliorer son cours. Son cours est l'un des meilleurs cours que j'ai pu enseigner avec le cours du professeur Luna Garbinato. Donc c'est 2 cours d'algorithme et de programmation. Et je le dis, je le pense vraiment, les étudiants qui les ont eus comme prof ont eu beaucoup de chance. Et sont des étudiants de sciences criminelles et également d'HEC. Ce serait bien que d'autres étudiants puissent profiter de ces cours et également de leur savoir-faire. J'aimerais remercier tous mes collègues du DESI, professeur Thibaut Estier, professeur Valérie Chavez de HEC, merci beaucoup d'être venu. Alain Maria, qui a décidé de quitter le master en système d'information. J'aurais bien aimé qu'elle fasse un doctorat avec moi, mais malheureusement elle a préféré gagner de l'argent. C'est ce que je peux comprendre. Bon, Aleida également, qui nous a beaucoup aidé lorsqu'on a des soucis en maths. C'est un plaisir de travailler avec toi. Et en dehors du DESI et de l'Université de Lausanne, j'ai également rencontré beaucoup de personnes, Ouisso, avec lesquels j'ai fait mon bachelor en Guinée, et la famille Sigam également. Alors, je vais vous dire, je vais vous donner une petite anecdote. J'appartiens à la première génération. La première génération de personnes qui ont eu la chance d'aller à l'école. Donc, si je suis là devant vous aujourd'hui, j'ai traversé beaucoup d'épreuves et c'était pas toujours évident. Mais je vais pas dire que c'est difficile parce que j'ai eu la chance de rencontrer ces personnes. J'ai rencontré la famille Sigam qui m'a permis de venir en Suisse, qui m'a accueilli sous leur toit et je vous suis infiniment reconnaissant. Et également, je vais regarder mes notes pour être sûr de n'oublier personne. Alors, très souvent on dit, lorsqu'on fait un doctorat, on n'a pas de vie sociale. C'est complètement faux. Tout simplement, peut-être, mon cas est différent des autres. Moi, j'ai eu de la chance d'avoir un superviseur qui me comprenait, qui me permettait de travailler et qui m'offrait la liberté de travailler comme je voulais. Et pendant mon doctorat, j'ai eu la chance de me marier. J'ai rencontré mon épouse qui a été très patiente envers moi et qui a accepté que je passe des nuits blanches et que je la délaisse pendant quelques temps. Je suis vraiment désolé pour ça, mais sache que ça en valait la peine. Alors, il faut également que je remercie Monsieur Gabriel Curtis, que nous suivons en ce moment, qui était le directeur de l'agence de promotion des investissements privés en Guinée. Et je l'ai eu comme superviseur, comme premier superviseur. Et il a une idée assez folle quand même. J'ai 21 ans, il m'a recruté et j'ai été responsable informatique de son agence. Et il m'a permis de rejoindre la Banque mondiale en tant que consultant. Et c'est ce qui m'a permis d'économiser, de mettre assez d'argent de côté pour pouvoir financer mon rêve de faire des études en Suisse. Et sans lui, je pense que je ne serais pas là aujourd'hui. Et je dirais pas uniquement sans lui, sans toutes les personnes que j'ai rencontrées présentes dans cette salle, sur Zoom, et les personnes qui nous ont quittés malheureusement. Je vous remercie tous. Merci.
Voilà, ceci clore la session. Merci.
Allez, il y a un apéro.